All right, in this video, I'm going to go over how to graph polynomial functions. This first page is really going over the difference between monomial, binomial, trinomial, and then polynomials. We're going to be looking at, in this lesson, polynomials that have degrees 3 or higher, so not the quadratics that we looked at in the first semester. We're going to talk about things that are not polynomials, like you'll see a couple of examples here with a rational function where x is in the denominator, and then this one here, which is going to have, that'd be like 1 over x squared, and then a combination here has a radical. So those are not polynomial functions. We'll be looking at things that have pretty high degrees, like I said, starting at 3, going all the way up to, I think there's one that might have 6, maybe even higher, 7 on the homework. And then looking at those in factored form to help us graph them. Okay, now this is probably the most important thing before we start actually practicing, is the end behavior, something you're going to have to memorize. And it really comes down to two things, all right? The first thing is what's called the leading coefficient, and the second thing is the degree. Now, when you're thinking about leading coefficient, right, there will be numbers, there will be signs, but the thing I want you to think about is it's either positive or it's a negative. Those are kind of the key things I'm going to ask about the leading coefficient. And for degree, which is the highest exponent in our polynomial, or when you see it in factored form, you'll see all the different powers on your binomials. We can just add those all up. That'll give us the degree. But I want you to focus on even or odd. All right, and that's going to tell us what's going to happen at the beginning and the end of our function, so the end behavior. So like in this first box here, all right, this would be if you have an odd degree. You should notice that the end behavior, they're going opposite directions, okay? For a positive leading coefficient, it's going to look like that, where it starts at the bottom left, goes to the top right. And for a negative leading coefficient, it's going to start at the top left and finish at the bottom left. All right, the other side of this is that if you have an even degree, so an even number, right? When you have a positive leading coefficient, it's going to have both of them are going to be going up, and a negative leading coefficient, both will be going down. Now, most students in the past that I've taught have no issues kind of memorizing this one. That's usually the one that's a little bit more straightforward because they're the same direction. But for the odd degree, going opposite directions, I'll give you some tips that I do in class or during class, some tips that I use to try to help me memorize it. But ultimately, it will come down to making sure you know how the end behavior works. All right, we're also going to find the y-intercept to help us sketch. And then because we're going to be looking at factored form, all right, our x-intercepts should be pretty simple to figure out. Now, the last thing before we get started is about multiplicities. All right, so kind of 3 different options here. The first one, the most basic one, is a multiplicity of 1, so it's not a multiplicity, or it's not a multiple, all right, which means that it's going to just cross through the x-axis. So this is your straight, run-of-the-mill, straightforward. If you see your binomial raised to the first power, right, you'll notice these don't have powers. This is going to just cross through. Then when we have an even multiplicity, or in this one here, is called a double root, or if you look here, we have a 4, right? That's an even number, right? This is going to touch or bounce off of the x-axis. So I'll be using both those words interchangeably. It's going to bounce and come back, or touch and come back. And then finally, this last one here is an odd multiplicity, but the key thing is the number is greater than 1. So you'll notice a triple root, and you'll see this here to the 5th power. Those odd numbers that are greater than 1 are going to what we call wiggle through. So they're going to cross through, but it's going to look a little bit different than the one that has just a single root. All right, so all that being said, all right, let's go ahead and practice, or actually look at one that's graphed for us, and then we'll practice 2 where we have to graph them. So this first one here at the bottom, all right, let's look at the degree, and I'm going to focus first on, you can do this with the graph or with the function. They gave us the function, so I'm just going to get the degree by counting, right? This is to the first power, so 1 plus 2 plus 3 is going to give us our degree. So that's going to be a degree of 6. Again, the key thing here is it's even. The leading coefficient, I look at the very front of the function. There's nothing there, so it's a positive 1. But again, the thing I care about is that it's positive. All right, so based on my end behavior, Right? I'm not actually, I don't need to worry about that because they already graphed it. But if I was asked for the end behavior, I would say that the end behavior is going to be both going up because it's an even degree with a positive leading coefficient. All right. Now for the y-intercept, this is where you're going to plug in 0. All right. So I'm just going to plug in 0 into the function. And whatever I get is going to be my y-intercept. Sometimes it'll be really easy because one of your x-intercepts will be 0. If one of your x-intercepts is 0, then the y-intercept is just the origin. But this one is not going to be that. This one actually will be a number other than 0. So that's 3. 0 minus 2 is negative 2 squared is 4. And then 0 plus 1, 1, 1 cubed is 1. So that's going to be 12. So the y-intercept is 0, 12. All right, and you can kind of see it here. Remember, they've already graphed it. But there's 0, 12. All right, in terms of the x-intercepts, and there's only 2 slots here, but I'll do one above it just so you get all 3. All right, so I'm going to go from least to greatest here. My first one is going to be negative 3, 0. Right, that's one x-intercept. Then I have negative 1, 0. Right there. And then finally I have 2, 0. Now you can get this from the graph. They've already done it. Or you could use the actual factored form, which is highlighted up there. All right. But when I look at that first one, negative 3 comma 0, that is just crossing through. It doesn't have any wiggling when it crosses through. So this is going to be that single root of multiplicity of, up here, 1, called a single root, which makes sense. If you look, the power is raised to the first power. Okay. Now, the description of the contact with the x-intercept, we're just going to write crosses through, which happens in that graph. The next one, going from least to greatest, is negative 1, 0. This one does cross, but you might notice, and I'll kind of highlight with a different color here, you might notice as it crosses, right, it doesn't cross like the x-intercept at negative 3 comma 0. This is going to be that multiplicity that is odd but greater than 1, and which makes sense because the number is a 3 in that power. So I'm going to put here, I'm going to put odd, and I'm going to put triple root, right, because it's raised to the third power. And this is going to be the one that we say wiggles through. All right, and last but not least, here we have 2 comma 0. That one is the one that touches, it doesn't cross through, right? This is going to be that even root, or in this case, double root because of that even number 2. So I'm going to say for this one, it bounces, or you could also say touches. Both of those are the same thing. All right. So what we're going to do for the rest of this video is I'm going to do 2 examples where we actually do all the same stuff we just did here to the right-hand side, but then we're going to do a quick little sketch. It's not going to be perfect because you'll notice on our sketch, we're not going to be able to go up to 30 or down to almost negative 40, right? That's something we can't do, but I'll do my best with the end behavior and the x-intercepts to give a nice sketch. All right, so here we go. Let's try this first one. Key thing is make sure it's fully factored. When I look at this x squared minus 9, I notice that that is not fully factored, right? That is the difference of 2 squares. So I'm going to factor this as x minus 3 and x plus 3, and then bring down my other ones. All right, so in terms of my degree, now all of these are to the first power, and there's 4 of them. So my degree is going to be 4, which I said is an even degree. My leading coefficient, when I look in front of that x, I see a negative sign. So my leading coefficient is negative 1, but the key thing here is negative. So here, let's do the end behavior. All right, what I'm going to do is it's even for the degree. So it's going to open the same direction, whether both up or both down. And because of that negative leading coefficient, the end behavior, they're both going to go down. Okay, in terms of the y-intercept, I'm going to plug in 0 for x. So the opposite of 0 times 0 minus 3 times 0 plus 3 times 0 plus 2. And this is going to be one of those where you realize very quickly that it's just going to be 0, right? Because of 0 times anything is just going to be 0. So my y-intercept is going to be the origin of 0, 0. In terms of the x-intercepts, I'm going to make this table now. All right. I have, in order from least to greatest, looks like I have negative 3, 0 first. Then I have negative 2, 0. then I have 0, 0, and finally 3, 0. If you're wondering where I got all that, what I'm doing is I'm looking at each of these factors individually and setting them equal to 0. So what would make all of those 0 are my x-intercepts. All right, so least to greatest. Okay, they're all going to be to the first power. All right, so they're all going to be single roots or multiplicity of 1. So this is going to be single root, and we're just going to say that it crosses through. So I'm just going to essentially just copy this for all of these in my table. Now, kind of the tricky one here on this first example is you do need to make sure that it's fully factored, right? You remember when we just did it, we saw the difference of two squares. So just be aware that don't just assume that it's been fully factored, right? When you try the homework questions, make sure you're looking to see if you can still factor. All right, so let's go ahead and plot some things here. So I have the 0, 0 is actually one of my x-intercepts and my y-intercept. Negative 3, 0, negative 2, 0, and then 3, 0. All right. If you want, you can plug in different numbers here. Like you'll notice negative 1, 1, or 2 for x. You could plug that in to see if any of them will be on the grid. I did that when I looked at the homework. You'll check my key out. For the most part, they're all off the grid, but you can go ahead and do it. The key thing I want you to do is make sure you get your end behavior right. Right, so they're both going to open. Oh, good start on it. They're both going to open down. Let's try that again. All right, so there's our end behavior. That one's down, and this one's going down. And then get the interaction between the function and the x-axis correct at the x-intercepts. Remember, they all cross through, so this should hopefully be pretty straightforward. There's nothing really exciting going on, so we cross through, we're crossing through, and then crossing through. All right, so something like that. Again, I know that it may not be exactly right. Like if you type this into a graphing calculator, it's not going to be perfect, but I'm hopeful that you get the general idea of the sketch. Okay, let's do one more, and then I'll make sure you guys start the homework. Okay, so this one is fully factored, and I notice when I look at my exponents, I see one is a 2 and the other one is a 3. So to get the degree, we add 2 and 3 to get 5, which is odd. And then there's nothing in front of that first factor, so my leading coefficient is 1, but I care that it is positive. So for my end behavior, I'm going to be starting at the bottom left and going to the top right. Remember, it's something you just need to memorize, and I'll help you with that in class. Okay, let's find the y-intercept. Plugging in 0, I get 0 minus 3 squared times 0 plus 1 cubed. This one is going to actually be a number that's not 0 because we don't have an x-intercept at 0, 0. So that's negative 3 squared, which is positive 9, and then 1 cubed, which is 1. So my y-intercept is 0, 9. Putting my x-intercepts down from least to greatest, I have negative 1, 0, and then I have 3, 0. All right, so that negative 1 x-intercept is coming from a factor that's raised to the third power. So this is where I'm going to put that it's odd multiplicity, but it is a triple root. So this is going to be the thing where it wiggles through. So it's going to cross, but it's going to cross a little differently than all of the interactions in the first example, letter A. The next one is 3, 0. That's coming from a factor that's raised to the second power. So this is an even multiplicity, and it's a double root. And this is going to be the one that bounces or touches. All right. Again, it's up to you on how you want to phrase it, but those mean the same thing. All right, so plotting this, I'm going to have 0, 9, my x-intercepts of negative 1, 0, and 3, 0, getting my end behavior correctly here. So starting at the bottom left, I know it's not really like at the bottom left, but it's in that kind of quadrant there. And then it's going to finish in the top right, so like this. Okay, and then that first one of negative 1, 0, I guess I should try again here to make sure I get the wiggle part. All right, so we're going to wiggle through at negative 1, 0. So I'll do my best to show you the wiggle through. It can be difficult when they're so close together. Hopefully you see the difference there. There's the y-intercept, and then this one is going to just touch or bounce. So I'm going to touch or bounce right there, and then continues on. All right, so there is my sketch for part B. So take a look at the homework questions. There are a lot of them to practice, but hopefully you'll get used to this process of finding the degree, the leading coefficient, help you with the end behavior, find the y-intercept, and then go through that table to look at your x-intercepts and write out the multiplicity and how it's going to interact when you actually do the sketch. All right, good luck.